So today we're going to be looking at systems of substitution. So we're going to continue on with learning about the infinite no solution, one solution. It's just there's going to be different ways that we're going to be looking at it now. So one of them is substitution, but let's do a little warm up. So to recap what type of systems there is one, none, and infinite solutions. One solution means that as x equals one number. No solution means that there is a number equal to a different number, and we put a slash to the equal sign. Now, infinite means that the same number on either side of the equal sign is the same. So let's solve this one. What we're going to do is we're going to distribute first, like always. 8 times 2 is 16x. And 9 times 2 is 18. On the left side now, we didn't do anything, so all we're going to do is bring it straight down. Okay, and then remember we want to combine all the x's onto one side, so which one has the most? The 16 has the most, so on the right, so we're going to subtract our 14x from our 16x. Which is going to leave me with a 12 equals 16 minus 4 is 2. And I'm going to bring down my plus 18. Now is x by itself? Nope, I still have that 18. What I need to do is get rid of the 18 so that way I can have 2x by itself and then I can move to the next step. So 12 minus 18 is going to give me a negative number. And it's going to give me a what? Negative 6. Now x is by itself. What I can do, well, it's by itself with its 2. So remember, if these two are touching, it means multiplication. So the opposite is division. So in order to get x completely by itself, where x equals something, I need to divide both sides by 2. A negative divided by a positive is a negative. 6 divided by 2 is 3. So what type of solution is this? One solution. Okay, let's get to our substitution. So our essential question of the day is, how can I solve a linear equation by using the substitution method? So by the end of today, you will be able to solve this question. So, substitution method is when you take one equation and plug it into one of the variables, such as y or x, in the second equation. So essentially, if I have y equals 3x plus 2 and y equals 2x plus 1, what it's saying is, see how y equals something? This is what y is equal to. I can take this and plug it in here to create my one equation equals the other equation. So let's get to our steps. So for our substitution method, the first thing we need to do is make sure both equations are in slope-intercept form. So it's y equals mx plus b. Our first equation here is in y equals mx plus b form, but our second one is not. So how can I get it to the y equals mx plus b? Well, I have 2 attached to y, right? What I can do is take my 2 and divide everything by 2 in order to get it to y equals mx plus b. 12 divided by 2 is 6x. 14 divided by 2 is 7. So now it is in, both of them are in y equals mx plus b form. So now our second step says to put the equations equal to each other. So what I'm going to do is, remember how I said earlier, this y is equal to this. So anywhere that I see a y in my first equation, that's where I'm going to put it. So I'm going to take this 6x plus 7 and plug it in right here. Remember, y is just a placeholder. So now it says I have 6x plus 7 equals my original 5x plus 30. So now it actually looks like what we've been talking about this whole time, the last few days. So the third step, let's see what it is. So my third step says we're going to solve for x and determine the type of system. So 1, none, or infinite solutions. So now I'm going to solve for it by getting my x's onto one side. So I know that this 6x is larger, so I'm actually going to subtract the 5x from this side because I want positive x's. So 6 minus 5x is x, or 1x, plus 7 equals 30. Okay. Now, is x by itself? Nope, it still has the plus 7. The opposite of a positive 7 is a negative 7. So I'm going to subtract 7 from both sides, and x equals what? 23. So what type of solution is this? This is a 1 solution. X equals only one number. So let's try a few practice examples. So let's try this one. So I know that I need to have my equations in y equals mx plus b form. So my first equation versus my second one, my first one's not in y equals mx plus b form. So what I'm actually going to do is take it and get y by itself. So in order to move the negative 5x, I have to add 5x to both sides. Remember, this x cannot be combined with that 9 because the 9 does not have an x. So now I have 5x plus 9. Okay. This y by itself? Nope. I have to divide everything by 2. So now I have y equals 5 over 2x plus 9 over 2. So now they're in both y equals mx plus b form. So, as you can see, if I plug it into it, it's going to give me some weird numbers, right? So, there is one thing that we can definitely do. We can definitely do one strategy for this one. If we're going to get nasty decimals like this, there's one thing we can do. Is at least one of my numbers equal to y? Yes. Okay. See how this is y equals 7x? What I'm actually going to do is plug it into here. Now, I have negative 5x plus 2 parentheses 7x. Okay. The reason why I'm not going to plug this big thing into the other one is because fractions are kind of messy. And if I can figure out a strategy to put my equations into each other and then solve that way, it works out perfectly. It's the same. So I'm going to distribute the 2. 7 times 2 is 14x equals 9. I didn't do anything to the negative 5x. So I can combine like terms, right? 5x plus a negative 5x plus a 14x is going to give me what? Well, it's going to give me 9x equals 9. Is x by itself? Nope. So x equals 1. So this is one solution. There's one solution to each of those equations. Let's move to the next one. So are both of these in y equals mx plus b form? Absolutely. So all I need to do is take one equation and plug it into the other. And it's totally fine if you take the top and plug it into the bottom. That's totally fine too. Remember, you're just plugging them into each other so that way they're equal to each other. Okay, let's get rid of this 1x here and subtract x from both sides. So 2x minus 1x is just x. Did I do anything else to these other numbers? Absolutely not. So I'm just going to bring them down. So now I need to get x by itself by adding 3 to both sides because both of those are going to cancel. And I get x equals negative 3. So this is a one solution as well. Interesting. Wonder if we're going to have any more. Remember, anytime you can pause this video, you can email me or Miss Stiles or ask any questions if you're not understanding. Let's move to the next one. Okay, so let's get these into y equals mx plus b form, because both of them are not. So I'm going to do the first one over here. And I need to get rid of the 3x to both sides to get y by itself. So 2y equals negative 3x plus a 2. And what I need to do is divide by 2 for everything. So a negative divided by a positive is a negative. 3 cannot go into 2, so it's going to be negative 3 over 2x plus 1. And then for this one, all I needed to do was just get rid of the 8. Y equals 3x minus 8. So now I'm going to plug this one into this one. Okay? So now I have negative 3 over 2x plus 1 equals 3x minus 8. I want to get all of the x's onto one side. So do we like negative numbers? Absolutely not. So we're going to add 3 over 2 to the other side. Okay, so since we have 3 plus 3 over 2, remember underneath every single number is an invisible 1. To make the denominators the same, I'd have to multiply by 2. So I actually have 6 over 2 plus 3 over 2, which would give me 9 over 2. So now I have 9 over 2x minus 8 equals 1. Is 9 over 2x by itself? Nope. So what I'm going to do is I'm going to add 8 to both sides, because the opposite of a negative 8 is a positive 8. So now I have 9 over 2x. Do you remember what happens when we want to have a divide by a fraction? Well, in order to do that, we'd have to multiply it upside down to both sides. So in this case, both of these would cross out, and you'd get x equals. Both of these 9s would cross out, and you get x equals 2. Because if you multiply straight across, 2 times 1 is 1, 1 times 1 is 1. So this is a 1 solution. So get these ones into y equals mx plus b form. Pause the video, and I'm going to do it for you. Well, I'm going to have the answers, but you need to pause it. Alright, so for the first one, you should have got y equals negative x plus 4, and the second one, y equals negative x plus 5. So now I'm going to set them both equal to each other. Negative x plus 5 equals negative x plus 4. I want all of my x's onto one side, so I'm actually going to add an x to both sides. Oh no, what happened here? I get 5 equals 4. What kind of solution is this? No solution. Oh no. So remember, if we wanted to show this, we need to put a slash through the equal sign and write no solution. Let's try the next one. Alright, last two. I want you to put both of these equations again into y equals mx plus b form. Pause the video and figure it out. Alright, so for the first one, you should have got y equals negative 1/2 x plus 5. And for the second equation here, you should have got y equals negative 1/2 x plus 50 over 6. Or if you put 8.33 continuing, that's fine too. So let's figure this one out. If we set them equal to each other, what you're going to get is this. And if I add 1/2 to both sides, or 1/2 x to both sides, you get 5 equals 50 over 6, which means no solution. So let's solve the last one super quick. Again, put these both into y equals mx plus b form. Alright, you should have seen that you got the same equation for both. So without even solving it, can you tell me what it is? Infinite many solutions! Woohoo! Now go on and do your summit work.